Hi, boys and girls. It's good to see you again. Mr. Cameron told me you'll be having an assessment soon, and it'll be on a mixture between chapter 9 and chapter number 10. So I'm going to review some of the key concepts so you'll be prepared for that assessment, okay? One of the important key concepts is the coordinate plane. You should remember this from last year. The coordinate plane being flat and extending in all directions, is really like a piece of graph paper, isn't it? It's also composed of an x-axis and a y-axis that cross at 0. Now notice those are number lines, aren't they? 0, the positive goes to the right. If it's up and down, 0 is right here, the positive goes up. The negative goes to the left, 1 through 13. I don't know if you can see that on my coordinate plane, but that's as far as I could get on mine. And then down is also negative, so these numbers are negative, okay? Now, when you plot ordered pairs, which I think you'll remember from last year, the X number always goes first. This is kind of like playing Battleship, except it's not a letter and a number. It's two numbers together. Let's look at the first quadrant. Notice it's designated by Roman numeral 1. Then you go counterclockwise. This is quadrant 2, quadrant 3, and then the last quadrant is number 4. Now, there's something special about each of the quadrants. Quadrant meaning 4, so divided into 4 sections. Okay? Both numbers will be positive in the ordered pair in the first quadrant. In the second quadrant, the first number, the X number, will be negative, but the Y number will be positive. In the third quadrant, both numbers will be negative numbers, and in the fourth quadrant, the first number is positive and the second number, or the Y number, is negative. Let me show you a couple examples of this. Again, mine aren't perfect, but please bear with me. This would be an example of two ordered pairs that are in the first quadrant, okay? This would be a 4 and 3, the ordered pair positive 4, positive 3, plotted right there. Then this would be 6, X is first, 8, positive 6, positive 8. Two positive numbers take place in your ordered pairs in the first quadrant. Now in the second quadrant, you'd have a negative number first. Let me line this up for you, please. Wait just a second. Okay, it's about as good as I can get it for you. This would be X being a negative 5, up positive 4. There's the plot or the ordered pair, negative 5, 4. This one would be negative 9 for your X, and 7, positive 7 for your Y. Those are two examples of coordinate pairs or ordered pairs in the second quadrant. Now in the third quadrant, remember we said they're both negative. So I'm going to line this one up for you as best I can. Okay. This would be a negative 6 for your X, negative 4. You go down, negative 4. There's your plotted point for negative 6, negative 4. Then we've got a negative 9, down a negative 9. There's your ordered pair. Notice again, in the third quadrant, they're always both negative. Now in the fourth quadrant, your X would be a positive. Let me line that up for you here. And the Y would be a negative. Here's where we would plot positive 4, negative 4. And remember, they're separated by commas and encased in parentheses. Here's another one for the fourth quadrant, positive 7. Remember, positive number comes first for the X number, and then down and to a negative 10. That's positive 7, negative 10. Those are your ordered pairs in the 4 different quadrants, okay? Hope that brings back fond memories of last year. Now I'm going to take these off, and sometimes we talk about slope. That's also coming up on the test in a few days. Okay, what is a slope? A slope is a ratio, and remember, ratios really looks like a fraction, which describes the vertical change, that's the up and down change, which we call the rise, to the horizontal change, which we call the run. Let me give you an example of this, okay? I'm going to use the first quadrant for this and put a positive 2, 3 on this one for you. Okay. Okay. Now, I know you can't see the lines, but trust me, that's positive 2, 3. And then I plotted a positive 5, 7, And I noticed it made a straight line with positive 8, 11. Notice again, they're both positive numbers. And I made a straight line. Now, what's that relationship between the rise and the run? Well, this is how I like to do it. You just count the spaces from this point to this point. So I've got to go 1, 2, 3, 4 spaces up and 1, 2, 3, 4 spaces to the right. That makes a fraction or a ratio 4:3. Let's see if it works for this one. 1, 2, 3, 4 up and over 3. That makes a straight line. It's got a positive slope because we're going uphill. Remember, things going up are positive. And the slope would be then 4/3. Okay, let me show you an example of a negative slope. Okay. Now, think of going downhill or doing poorly on a test. That's pretty negative, isn't it? So when you see a line like this, that's definitely negative. Okay, now here's where I plotted for you -3, 2. Remember, it's in the second quadrant. -3, 2 is right about there. Then -6, 7. And if I were to continue, I'd have a straight line going on into infinity. Let's see what this slope is. This is interesting. Now look, watch. 1, 2, 3, 4. Okay, up. And then 1, 2, 3, 4. Run or across, which is 4/4 or 1/1. And let me prove to you how it's really 1/1 too. Because look at all these points. All of these would have the same slope of 1/1. We could pick any pair and they'd all equal 1/1. Okay, now sometimes there's such a thing as no slope. Let's start with this one, +4, -2. Okay, and if I had a +8, -2, and a +12, -2, what would happen? I'd end up with a straight line. All my ordered pairs are across from each other. We call that really a zero slope, or I like to say no slope. So are there such things as positive slopes going up, negative slopes going down, and no slopes as well? Okay, now this is great when your numbers don't go beyond 13, like my graph does. What happens if you end up with an ordered pair like this? Ordered pair 35, 5 and 38, 10. I don't have room to plot those points. There's a formula, which is very simple. It will let you find a slope for any two ordered pairs, no matter how large they are. And here's what the formula is. For some reason, they pick M for slope. I don't know why they didn't pick S, but they picked M. Okay, slope equals take the second y. Now, that's not y squared. That's the second y. Okay, and then minus the first y from it. And put that over the second x minus the first x from it. Now watch this. This is neat. The second y was 10 minus the first y, which was 5, okay? The second x was 38 minus the first x, which was 35. You subtract those and you get 5/3. And if you want to prove me wrong, but you won't because this is the slope, 5/3 for these two ordered pairs. I won't do that because my graph is not large enough to show you that. But that's how you find a slope. When the numbers are too big to graph and you just want to do it quickly, remember this formula. The second y minus the first y over the second x minus the first x. And you can pick any ordered pair on the line that you're talking about, okay? Now, there's something else that figures do sometimes when we have a need to move them on the graph. Okay, here's a larger now quadrant, okay? And transformation is a fancy word for the movement or the change of polygon shapes that we can put on a piece of graph paper, coordinate plane. Okay, let's start with a translation. There are 3 of them: translation, reflection, and rotation. I'll start with translation. Translation is a fancy word for a slide. Okay, here's a square. I'm going to start right here and watch. If I go up 3 spaces and then move to the right 3 spaces, it ends up here, doesn't it? It slid over to that new position. That's what's called a translation or a slide. It didn't turn, it didn't flip over to the other quadrant. It just slid up. It could slide up, it could slide to this direction, any direction, but that's definitely a slide. Now there's a reflection. Let's start with this little dot right here on this equilateral triangle. If I were to flip it over is like a mirror image, okay? I would have a reflection. The yellow is a reflection of this. okay? Whereas this point is a +1, +3, this point would be a -1, +3. It just flipped over the y-axis, didn't it? And then there's such a thing as a rotation, okay? That's when something turns. Think of an ice skater. When he rotates completely around, he's making a 360, okay? Well, figures can rotate as well. Let's look at this equilateral triangle now. See the black dot? Let's rotate it around this point. How long does it have to rotate until it looks like the yellow one? Right about there, right? Well, now this is interesting because this is equilateral. All sides are the same. This is a 120-degree angle, okay? It took a 120-degree turn for that to look like the first one. Now, if we start rotating this rectangle, okay, watch what happens here. I'm going to rotate it 90 degrees. Does it look like the yellow one yet? No. I'm going to rotate it 180 degrees. No, doesn't look like it yet. No. I'm going to rotate it again this way, 270. Nope. And another 90 degrees would get me into the original position. So this one, see, just got rotated 360 degrees. So figures can rotate. Figures can flip over the axes. This one could also have flipped over the x-axis too. I just showed you one flipping over this axis. And figures on a coordinate plane can also slide. Okay, that's about it for now. I wish you a good luck on your test coming up the end of this week. And again, if you have any questions ever, feel free to email me at swidrickp@olgcparish.net or tell Mr. Cameron and we'll try to review it for you in another way.